Hi everyone, today we're continuing our discussion on reciprocal functions, but today we're taking the reciprocal function of quadratics. So this is quite a bit different from linear functions because linear functions are either always increasing or always decreasing. They always have exactly one x-intercept, so basically they're a lot more predictable. Quadratics, there's a lot more things that vary, so then that just means that with the reciprocals, there's a lot more things that vary as well. So let's just take a look first at our basic quadratic, y equals x squared. Okay, I want you to think about what you think the reciprocal is going to look like. Okay, I have it all geared up here, 1 over x squared. All I have to do is push this button, but let's think about it. So remember what we know about when a function is increasing, its reciprocal will be decreasing. Okay, so here we have our quadratic decreasing. So that means our reciprocal will be increasing. Here we have our quadratic increasing, so our reciprocal should be decreasing. Okay, what else do we know? We know that anytime there's an x-intercept, that corresponds to a vertical asymptote in the reciprocal. That's because when you get y equals 0, in the reciprocal, that would correspond to 1 over 0, which blows up the expression, okay? So we're going to have a vertical asymptote here at 0, okay? We also know we're going to have a horizontal asymptote at y equals 0 because if you have 1 over x squared, nothing that comes out of that will give you a number of 0. Okay, finally, notice that this entire quadratic is in the positive quadrants. So that means that the entire reciprocal will be positive as well. Remember, that's because if your y values are positive, then 1 over those y values will also be positive. Okay, so basically in this section, it's going to be positive, increasing, and there's an asymptote here and here. In this section, it's going to be positive, decreasing with an asymptote here and here. Also remember that they will intersect each other where y is equal to 1 or where y is equal to -1. So that will correspond to points of intersection here and here. So now let's click this. All right, so it meets all the criteria that we discussed. Okay, so the points of intersection, the intervals of increase and decrease, the positive intervals, and the asymptotes, as you can see. So as we move around this parabola, everything will change along with it. So notice that I set this up in vertex form. So as I make these slides, you can see what happens. So the vertical stretch isn't going to do much, okay? Basically just means that the reciprocal is also just a bit more stretched or a bit more vertically compressed in this case, as you can see. But you can visualize what's going to happen if I have a negative a value, okay? So if I flip down, then my reciprocal just flips down as well, okay? Because everything is negative, so then the reciprocal will be negative. But it gets a little bit trickier when I move up and down, or left and right. So if I change my h value from 0, it's going to move left or right. So if I'm moving to the right, notice that my reciprocal just moves right along with my parabola, okay? So in this case, there's an x-intercept of 3, my asymptote's at 3, so my intervals of decrease go to 3, so that means these increase from 3, etc. So basically, the reciprocal just follows along with that. Now, where it gets really quite a bit different is when we start having more than one x-intercept, okay? So when this goes up, there's no x-intercept, okay? If I raise this higher, look what's happening here, okay? So in this case, there's no x-intercept at all because it never crosses the x-axis. So that means that this reciprocal actually has no vertical asymptote. So it will increase and increase and increase and increase until it hits where the vertex is, and then it will decrease and decrease and decrease and decrease. Now notice, the point where the quadratic has a minimum, the reciprocal has a maximum. Now that makes sense because of the intervals of increase and decrease, okay? So if I flip this upside down and make it have, okay, so let me say I want a negative a value, but don't look at this yet. I want my k value down here. So then here's a case where I have a maximum on my quadratic and a minimum at the same x value for my reciprocal. So notice that if my k value is, let's say, -2, so if this vertex is at 0, -2, then this vertex is at 0, -1/2, because remember the y values are just 1 over the y value of the original. Okay, so let me put this back up here, an a value of like 1, positive 1-ish. So look what happens. Okay, put my k value back. So as I go across the x-axis, look at something like this. Look at that reciprocal. The reciprocal is that entire red thing. It's pretty cool. So what's all going on here? Well, my original function has two x-intercepts. Okay, so right here, whatever that is, and here, whatever that is. Okay, so that means that my reciprocal will have two vertical asymptotes, right, that go right through the zeros of the original function. Okay, so that's why this red part will go from y equals 0 up to this vertical asymptote, which isn't pictured, but that's where it is. And then this one starts from this vertical asymptote and then again curves around with y equals 0, the horizontal asymptote. So what happens between those two asymptotes, though? So between the two asymptotes, that's where this little vertex section is happening. So the reciprocal will also have, it's not really a vertex, we don't really call it that, but it will also have a maximum or a minimum. So it will come up from approaching those vertical asymptotes. So again, this one is increasing and then decreasing because the original function is decreasing and then increasing. So you really have to get your brain wrapped around understanding how functions relate to their reciprocals to be able to sketch these from scratch, which you will be doing. Okay, so it all kind of starts with understanding that the vertical asymptotes are at the same places at the zeros, and understanding that there's always a horizontal asymptote at y equals 0, and then figuring out the shape around those. But starting with the asymptotes is really the most useful. Okay, so you can play around with this. If I move k even further down, you'll notice that my quote-unquote maximum goes even further up because it's becoming a smaller fraction. Okay, if my k value is like -1/2, like between 0 and 1, I'm trying to make it -1/2, then notice that my reciprocal has a vertex value, I guess, of 2, because again, 1 over -1/2 is -2. So notice if they do go down here, though, the points of intersection are still where y is 1 and where y is -1. So notice that in this case, the quadratic and this reciprocal actually have 4 points of intersection. And they occur, again, when the y value is 1 and when the y value is -1. So 4 different places. Okay. If I make my k value go up positive here, but then flip it down, you'll notice that, again, I have quite an interesting parabola. So this would be, I'm trying to get some zeros here that are, so here the zeros are about at -1 and 1. Okay, so the asymptotes that are at -1 and 1. Okay, this has a maximum on the quadratic, so a minimum on the reciprocal. So anywhere where the quadratic is negative, the reciprocal is also negative. Where it's positive, the reciprocal is also positive. Where it's increasing, the reciprocal is decreasing. So here and then here it's also decreasing. And anywhere where the quadratic is decreasing, the reciprocal is increasing. So in this section and then again in this section. So notice here it's positive. Sorry, the quadratic is positive and decreasing. So the reciprocal is positive but increasing. In this section, the quadratic is negative and decreasing. So the reciprocal is negative but increasing. So these are the type of things you need to think about. So again, coming up with the asymptotes first will create distinct sections where you can think about what's happening. So let's go to the note. So we're starting with like a bit of a exploration for you guys to help consolidate these ideas. So notice I just came up with a relatively simple quadratic for you to graph. Okay, x squared minus 4. So its vertex is just at 0, -4. 1, 2, 3, 4. Okay, and it just has an a value of 1. So you just go over 1 and up 1 and use symmetry to find the next point. And then go over 2 and up 4. So notice I picked zeros that were integers so that wouldn't confuse you too much. And then over 3 and up 9, which I don't really have space for. So it would be about here, right? Your next point. So we can graph this parabola. So beautiful, Mrs. Weems. Okay. All right. So that is y equals, or sorry, p at x equals x squared minus 4. Okay, so we're going to look at this and start graphing our reciprocal function. So the reciprocal function then would be 1 over x squared minus 4. And I'm actually going to factor this just so we can see it in factored form. This is just a difference of squares, so it could be x plus 2, x minus 2. So this also could be 1 over x plus 2, x minus 2. Okay, so the zeros of this function are x equals 2 and x equals negative 2. And then, so that means here the vertical asymptotes are the same thing, x equals 2, x equals negative 2. So I'm going to go scroll back up and actually sketch those very skillfully on my screen. Okay, and then you want to label them with the equation, please. Okay, please use a ruler. I would if I could, believe me, it would look a lot nicer. Okay, so those are my vertical asymptotes. Then I'm going to look at the intervals over which the graph is above the x-axis, so where it's positive. So in this case, the parabola is positive before negative 2 and after 2. Okay, so that means that the reciprocal will be the same thing because they're positive in the same location. And that makes sense, right? Because if y is positive, 1 over y is also positive. It's negative between negative 2 and 2. So that means that my reciprocal will also be negative between negative 2 and 2. Again, because if y is negative, 1 over y would also be negative. The intervals on which the function is increasing. So the function is increasing everywhere past the vertex. So that means that that's where the reciprocal is actually going to be decreasing because they switch. So my original is decreasing anywhere less than 0. And so that means my reciprocal will be increasing everywhere less than 0. Okay, so those switch. Points where the y value is 1. So I actually have to do some work to do that. You have to set x squared minus 4 equal to 1 and solve it. So that gives me x equals plus or minus root 5 if you rearrange. So root 5, comma 1 and negative root 5, comma 1. So then those would be the points of intersection. So they would also occur on the reciprocal. Okay, where it's negative 1, so I'd set x squared minus 4 equal to negative 1. So then I'd get x is equal to plus or minus root 3 when I rearrange. So I get root 3, 1, and negative root 3, 1. And then I get the same thing over here. Okay, my local maxima. So notice that this has a minimum at 0, 4. So that means that my other guy will have a maximum at 0, 1/4. Okay, resist the temptation to say it's at 4, 0 and switch the two coordinates. Remember, that's not reciprocals, that's inverses where you switch x and y. Reciprocals, you take the y value and flip it upside down, so be careful. There's no horizontal asymptotes on my quadratic, but reciprocals of quadratics will always have a horizontal asymptote at y equals 0. Okay, so let's go up here and sketch this now. So I know that my local maximum will be at 0, 1/4. And I know that here in this section, this is decreasing and negative, so I will be increasing. And I know that they're going to intercept here where y is negative 1. So this doesn't look as much like a quadratic. It's much flatter at the top, and it looks like this. and then we'll be approaching the asymptote. Sorry, approaching the asymptote. I shouldn't curve away. And approaching the asymptote. Okay? And in this section here, they're going to intercept at 1 and 1. So it's going to be increasing and positive. So it will be approaching from the asymptote and then approach the other asymptote. And then same thing over here, from the asymptote, approaching the other asymptote. Okay, and I should also label the asymptote y equals 0. So now this red is g at x equals 1 over x squared minus 4. And there you go. Isn't it just gorgeous? All right, so we have that all filled out. Everything matches. Isn't that just beautiful? Okay, so all y coordinates of the reciprocal function are 1 over y, just a refresher, and a function and its reciprocal intersects at points where y equals 1 and y equals -1. Okay, so quadratic functions and the reciprocals have all the same conclusions as linear functions. So make sure you also refer to your last note. You don't just skip over reading that italicized portion, because that stuff is all super important still with quadratics. I just didn't feel the need to reprint it again. The only things we have to add is about the minimums and maximums. So if the original quadratic has a local min at hk, the reciprocal will have a local max at h, so the same x value, but 1 over k. And if it has a local max, then the reciprocal will have a local min at, again, h and 1 over k. Okay, I want you guys to be able to tell me why that's true. Okay, again, it's because the intervals of increase and decrease. So a maximum on a quadratic happens when you go from increasing to decreasing. And if a quadratic goes from increasing to decreasing, then the reciprocal will go from decreasing to increasing. And that's why it has a minimum rather than a maximum. So it all ties back into the intervals of increase and decrease. Okay, so if I ask you to describe that, now you can. All right, so here is a question I want you to graph this, and it's reciprocal. Okay, so the first thing you need to do is factor this to get the zeros. So when you factor it, you get 2x plus 3 and x minus 2. So the first thing we do is we find that the zeros are at -3 over 2 and 2. Okay, the vertex, if you use minus b over 2a, you get a quarter, so x equals a quarter, and y equals minus 49 over 8. Which, let me think about that, 8 times 5 is 40, so it's, but 6 times 8 is 48, so it's just above -8. Okay, so, sorry, 6 times 8 is 48, so it's just below -6. So 1, 2, 3, 4, 5, 6. So your vertex is about there. So that's kind of enough to draw your quadratic. You can find the y-intercept as well, but because the vertex is so close to the y-intercept, I'm not really worried about it right now. Okay, so what does that mean for my reciprocal? So that means that my reciprocal, I'm using a different color, will have vertical asymptotes at x equals minus 3 over 2 and 2. So let's draw those. And label them. Again with a ruler. Okay, and it will have a max at a quarter, and then I flip this, minus 8 over 49. So that's like some really stupid tiny little fraction. It's about there. Okay. So from there, I can think about where it's increasing and decreasing. Okay, so in this section, it's going to intersect at where it's 1, where it's 1, and where it's -1, and where it's -1. So to find those exact coordinates, if I ask for them, you would set 2x squared minus x minus 6 equal to 1, and then do the same thing for 2x squared minus x minus 6 equal to -1. Rearrange, use the quadratic formula, and solve to find those exact coordinates, okay? So then you can analyze all the information. So this is decreasing in this little section. So that means that my reciprocal will be increasing in positive and basically get right up to those asymptotes. In this section, it's increasing in positive, so this will be decreasing in positive. And here I'm going from increasing up to my maximum and down to decreasing. So there you have it. Okay, so if I ask for analysis of how you came up with this, you're basically doing the same thing that you would in the chart I did above. You're looking at positive and negative intervals, intervals of increase and decrease, points of intersection, and all of the asymptotes. Okay, and that's outlined all in that chart for you from the very first example. Okay, final example. Here we're given a reciprocal, and I want you to come up with the original equation and solve it. So notice here that there is no local minimum or local maximum, and that's because it must only have one x-intercept, okay? There's only one vertical asymptote, which is extremely straight and well drawn, at x equals 2. Okay, and so the VA is at x equals 2. Sorry, x equals 2. So that means there is only one x-intercept at x equals 2. So therefore, that has to also be the vertex. See what I did there? Okay, if there's only one x-intercept, that has to be the vertex. Okay, and because we go from, it's all positive, so therefore my parabola is all positive, so my A value is positive, since the reciprocal, since g at x is all positive, so I have to be all up here. And I'm going decreasing up to increasing, okay? And I'm going to be intersecting at these points, okay? So I'm going to do that up here. And I notice that they occur when x equals 3. So this is the point 3, 1, and this is the point 1, 1. So that is consistent with an A value of 1, since when you go over 1, you go up 1. So basically, my original function then would be x minus 2, because it's gone over 2 squared. It's easiest just to do it in vertex form. So that means that g at x is 1 over x minus 2 squared. Again, I know my A value is 1 because when I go over 1, I'm going up 1, which is consistent with an A value of 1. And I know that because those are my points of intersection where y is equal to 1. All right, so take a look at the success criteria. These all relate specifically to quadratics, but I want you to also take a look at the last one. You're also expected to, there's one question in your homework where they give you graphs of reciprocal functions of other types of parent functions. So a square root function, an exponential function. So that really tests, do you understand how we developed these reciprocals, or are you just memorizing how they look for linears and quadratics? So that's that level 4 critical thinking style that I'm looking for the really those of you who want to study this in university or really take an interest in how these things are connected. It's really kind of fun to figure that out. If you can take and you can be successful at it, it's really quite rewarding. If you can understand why these things are happening. Remember, a reciprocal just takes the y value and flips it upside down. So instead of y, you have 1 over y. So all the behavior is related to understanding that that is what a reciprocal actually is. Okay, so please, if you're having trouble, come see me in class. Don't let this go. We're going on to more difficult rational functions after this note. So we just have these 2 days of reciprocals, which is when you just take, it's 1 over a function. After today, it's going to be a function over a function. So I hope that this was informative for you and that you learned lots.